Okay, now let's start our maximization case. All constants of the type less than and equal to. And then we will talk about the case where it is a mixed constants, maybe less than or equal to. And then third type, we will talk about the minimization case, right? And then a little bit different perspectives, like if there is a tiebreakers, if how we will solve for the unbounded solutions, how we will solve for the multiple optimal solutions. So like that examples, we will also do it. So as of now, let's start with the maximization case. Okay, let's start with one of the questions. It says, a firm makes two types of furnitures, chairs and tables. Profits are rupees 20 per chair and rupees 30 per table. Both products are produced on three machines, M1, M2, M3. The time required for each product in hours and total time available in hours per week on each machine are as follows. Okay, table is given where we have chair, table, available time. Machines are M1, M2, M3. Okay. So how should the manufacturer schedule his production in order to maximize the profit? You have to solve the simplex method. In the exams, it would be given and you have to solve it by the simplex methods itself. So first step of simplex method is formula. Let me solve it. Take the black color. First is formulate the problem. That's the first step of simplex method. We will solve in a very, very simple methods. I will teach you step by so that it would be easy for you. Right? So in the at the formulation, let x and y be the number of chairs and tables to be produced per week, because in the question is given per week and respectively. If in the question it would have been given in a month, you have to calculate how many chairs and tables you have to produce in a month. Then you can take it as a per month. It's given per week. Everything is given in per week, right? So we will take it per week itself. Now, objective function, I already explained you in the previous video and the class how to formulate it. So the objective function which is required, first of all, objective function, it's a maximization case. Maximization of profit. Because you have to calculate the profit. So it's a maximization case. And in the maximization of what? The profit. So first is, we will write the objective function or maximize Z equals to 20x plus 30y. Why I'm using 20x and 30y? See, is given profits is 20 per chair and rupees 30 per table. If you're producing one chair, you are getting rupees of 20 rupees profit. But here we are producing X number of chairs, so profit would be 20x. And the same way, for one table is rupees 30, and we are producing the Y tables, it would be 30 multiplied by Y, that is a 30y. And the total profit would be, we are adding both the things, 20x plus 30y. Right? Now, these are maximization objective function. Now, they are subject to constraints. I told you in the previous class, always we have to add some constraints are there. So what are those constraints? We have to write subject to constraints, and constraints are, as we know, in machine 1, we have 3 hours in per week is available with us. For the chair, it would be 3x. For if we have to prepare for the x tables, then it will be 3x. And for the table, it is 3, then it would be 3y. And we know we have the available time per week is 36. So it would be less than or equals to 36. Is it clear? This is available with the machine 1. In the same way, second constant would be, it's a 5x. You can see I'm talking about this is for the second constant. For the third constant, I will go for the next, for the M3. Now 5x plus 2y, which is less than, and because available time is 50 hours per week. It is 2x plus 6y, which is less than or equals to 60. Available time over here, this is for the machine 2. This was for the machine 3. These are the three constants. An important point, which I told you, don't miss it. All the variables x and y here needs to be more than and equals to 0, non-negative constraints or restrictions. Three things I told you. One is objective function is necessary in formulating the linear programming problem. First thing is maximize or minimize, whatever. So objective function is required. Second, you are supposed to write the equations of the inequality equations of the subjective constraints. Third point is non-negative restrictions. These 3 points are important in formulation of the table. Don't miss any of the 3. Right? Sometimes we feel like, yeah, we know it's obviously it's more than and equal to 0 or something constant. We can do it, solve it directly. In the exam, directly we will keep it in the table. Please don't do that, because this carries some percentage of the marks distribution is there for this also, for formulation of the table. Now, when you have formulated the table, the second would be standardization of LPP. You have to frame, this is an inequality, and you have to frame the standardization of the linear programming problem, where you have to introduce slack variables. I'm writing slack variables only over here. At the time of the standardization of LPP, you can include slack or the surplus variable as per the requirement. In the previous session, I explained you how we solve for the slack variable and the surplus variable. I think it's clear to you. In the slack variable is only used when it is a less than and equal to. Over here, our all constants are less than and equal to. In all the constants, so that's why I will introduce the slack variable itself. If it would have been the more than or equal to somewhere, then I would have gone for the surplus. Or if it has been the mixed, in less than, we will put the slack variables. In greater than, we would have put the surplus variables. Right? Hanji. Now let's go for the next. How next would be 3x plus 3y. Now to make this inequality into the equality. Or I can say we have a like plus S1 equals to 36. Because something is required to be equated. Now like that, S1 is slack variable. I will write S1 is slack variable. Or I can say we are capturing unused capacity of time on machine M1. Because S1 is for the machine 1 case, so we will say this is a slack variable, and generally slack variables are the unused capacity. And over here we are adding the slack variable. This is the variable which is unused, right? So like that for the second also 5x on the second machine 5x 2y plus S2 equals to 50. Simply what we are putting the slack variables adding into it. I'm explaining in a very simple and slowly. You can solve it with me and do it. In the third equation, the machine 3, I have added the another slack variables, that is the S3. And this is S2 is also the slack variable, and which is capturing the unused time or the hours spared time on machine 3. And the same thing is for the machine 3. Now, over here, when we have added on the constraints, our LPP problem will become, we have to add the objective function first. Objective function says z equals to 20x. Or before that, let me explain one part. Over here, now the variables will be x, y, s1, s2, and s3. They all needs to be more than and equals to 0 for the non-negative restrictions. Is it clear? Now, for the objective function, as we have added s1, s2, s3 in this solution, if you will see, we have added s1, s2, s1, s2, s3 in the solution. And their coefficient have to be determined. We need to what they would be the coefficient. Because in the LPP, we need the Z objective function. Objective function obviously is a maximization case which we are going on. Z equals to 30y, 20x plus 30y plus now some coefficient function of S1, some coefficient function of S2, some coefficient function of S3. Now what would be the coefficient function of S1, S2, S3? As we have added S1, S2, S3 in the solution, their coefficients have to be determined and the objective function should be modified by including all and every variable in the system. Whatever the variable we are using, that needs to be added into the objective function. That's why we are making this into the standardized of LPP. The coefficient may represents the cost involved in not using the timers. Because if you're not using the timers, it means it's a cost is involved still. So we shall presume that unused capacity or resources, these unused capacity or these unused resources have no cost. And as such, they do not affect the profit. We are assuming it. We are presuming it. Whenever we add the slack variables or surplus variables, we assume or presume that unused resources have no cost. And as such, they do not affect the profits. If there is no cost is incurred, then no profit. Well, they're not impacting the profit. Thus, the coefficient assigned will be zeros to them. Right? So, in the objective function, whenever we are using unused or the slack variables or the surplus variable, we give them the coefficient as a 0. Because for this x, coefficient is already there, 20, 30, here 0, 0, and 0. I think it's clear. Right? We can say S1, S2, and S3 are amount of unused hours on machine 1, M2, and machine 3 respectively. Is it clear? I think it's clear. Now we got the standardized formulation of LPP. Now, this was the first step was formulate the problem. Second was standardization of LPP. Now, third part. Third is set up initial basic feasible solution. I'm explaining you the concepts before we are coming for the table of the simplex. Right. Now, we know n equals to number of, let n equals to number of a variable in standardized form. In the standardized form, consequence x1, x2, s1, s2. Means we can say there are 4 variables. Yes or no? So first of all, we will allocate how many, we have to calculate how many number of variables do we have in the standardized equation, in the standardized form of LPP. Not on the basic one, but on the standardized one. That we will calculate. We know they are the 4 variables, right? Then we have to see M, which are number of constraints. Number of constraints in standardized form. Again, in the standardized form, we will check. Now we will considering only the standardized form. How many constraints we have? We have the two constraints, right? Sorry. We have variable S3 also. We have 5 variables. Here we have 3 constraints, right? Machine 1, 2, and 3. The other 3 constraints and variables S1, S2, S3. Yes. Now we have n is equals to 4, we can say, and having the habit of writing that down. M equals to 3, right? Where we know n is more than m, right? In that case, a solution may be obtained by a setting, right? So that you remember a solution is or may be obtained by setting m by setting n minus m variables equal to 0. As in the previous class, I explained how to calculate the initial basic feasible solution, but still I am explaining you in a different way or in the detailed way. Still, if you have any doubt, please go ahead with the previous video where you will understand this part too. Variables equal to 0 and solving for remaining variables. Remaining variables. Like a solution may be obtained by setting n minus m variables equal to 0 and solving for remaining variables, right? So it would be easy. So variables, those to whom we will write as a 0. कुछ वेरिएबल्स ऐसे होंगे जिनको हम 0 बना देंगे. जो 0 होंगे हम उनको बोलते हैं नॉन बेसिक वेरिएबल्स, है ना? वेरिएबल्स विल बी वेरिएबल्स those will be and basic variables are those which are non-zero. Variable those will be 0 and will be 0. Okay? Now, in simplex, we start with in this simplex. We start from origin. Let's start from origin. Always we start from origin. Start from origin. That is, we are keeping x1 equals to 0 and x2 equals to 0. If we solve x1 equals to 0 and x2, over here it's not x2 in our question, it's y. Yeah, x and y. We are keeping x is equals to 0 and y equals to 0. In that case, if you will solve them, put these values of x equals to x1 0 and y 0. Right? You will get the values of s1 equals to 36, s2 equals to 50, and s3 equals to 60. How you will get it? Ye 0, this is 0, then s1 is 36. S1, S2, x and y is 0, then S2 would be 50. X1, y 0, then S3 equals to 60. Is it clear? Then we get the value of S1 36, S2 50, and S3 60. I think it's clear. If it is the case, then we know Z would be 0. As there is no contribution, we can see X is 0 means 20 into 0 is 0. 30 into 0 is 0. Now 0 into 36 is 0. 0 into 50 is 0. 0 into 60 is 0. So means in total, Z comes out to be the 0. Is it clear? This is the basic feasible solution. The basic feasible solution, we can say basic. I'm teaching you in a simple. Then we will come to the table, simplex table. Our basic feasible solution is x equals to 0, y equals to 0, s1 equals to 36, s2 equals to 50, and s3 equals to 60, and z equals to 0. This is my basic feasible solution. Now, I need to calculate the optimal solution. To calculate the optimized busy solution, we have the method of simplex by which, first of all, we will make one table. This basic feasible solution is summarized and we have to put it in the simplex table 1. We will start with the first table and then to the second and then third, fourth if it's required. And how we go from the first one table to the second, I will explain you in detail. So first of all, understand how we make the initial basic feasible solution and summarize into the table. Right? So whenever we write the table, let's start with first thing is the first column would be the Cj. What is Cj? This is a contribution to the objective function. What is the contribution of the basic variables to the objective function? Then second is your basic variable. Then third, we will write the solution of the basic variable solution. And then we write what all the variables we have or whatever the key decision-making variables or decision variables or structure variables we write x, y, s1, s2, and these five are my variables in this. And there over here we write their coefficients. It's a 20. Sorry, my bad curve. Okay. Okay, over here. Consider this. And we are placing it in the table over here. It is 30. It is 0, 0, and 0. Is it clear? Make this table. Make the proper table. Use a ruler or the way, make the straight lines and like that, make the proper table in the exam. Okay, now see, what are my basic variables? Just now I told you the basic variables are those variables, those are non-zero. And in our answer or in our basic feasible solution, what are the non-zeros? These S1, S2, S3 are your non-zeros. So my basic variable would be S1, S2, and S3. These slack variables were now in my first basic feasible solution are coming up in the initial basic feasible solution. Right? Now, what's their contribution to the objective function? I'm again writing what it is. This is a contribution. Contribution, right? So what's the contribution to the objective function? Is 0, is 0, is 0. And what was the solution? We have just solved. S1 was 36, S2 was 50, and S3 was 60. Now, these are the coefficients which we will write. For x, the coefficient is, come to their standardized equation. This is for is 3, here 5, here 2. Right? 3, 5, 2. So I'm writing it 3, 5, 2. For y, again check the standardized 3, 2, 6. I'm writing it back 3 in the table 3, 2, 6. Now for the S1, we know S1 was introduced for the first, right? For the first machine. And for the rest of the machine, it was 0, 0. And for the S2, it was 0 for the S1, but it was introduced in the second constant, it was 0. 0, 0, like this. You will observe that they are in the unitary matrix. We are getting it, right? I will explain you how the interpretation of this body. In a full interpretation, I will explain. Because interpretation is also very important from the exam's perspective. Then only you will be able to solve it. Solve to aap kar loge, but interpretation is also equally important. Now, you have, I think, till this point it's clear how to make the table of the simplex. Then we write the ZZ. What would be the profit? We know how we calculate the profit. We calculate the profit by whatever the solution multiply by how much their contribution to the profit, to the objective function, plus this one, plus this multiply this. We know they are contributing 36 multiplied by 0 plus 50 multiplied by 0 plus 60 multiplied by 0 is contributing 0. Is it clear how we are calculating it? Okay. So I can say the contribution, as of now, my solution's contribution is 0 to the profit. If I'm not producing S1 or X and Y, in that case, my profit is 0 because they are not contributing anything. These like variables, right? So now in the same way, we will check for the X, Y, S1, S2, S3. When X1 for the 1 unit of X1, if 1 unit of X1 is introduced in the solution, if 1 unit of X1 of X is introduced, 1 unit of X is introduced in the solution, right? Where X is 0, right now we have X is 0. If in place of S1, we are introduce this X, right? We need to sacrifice 3 units of S1. Right now, 3 is S1. So if we want to introduce X in place of S1, at the time we have to sacrifice 3 units of S1. I think it's clear. First of all, let's the contribution 3. If it would have been 3, then what's the contribution? Same way, 3 multiplied by 0, this multiplied by 0, plus 5 multiplied by 0, plus 2 multiplied by 0, which comes out to be this multiplied by this multiplied by this, because their contribution is 0. So the answer would be 0. I think it's clear a little bit. In the same way, it would also be 0, 3 into 0, 2 multiplied by 0, 6 multiplied by 0. Then all adding up, this comes out to be 0. In the same way, 1 multiplied by 0 is 0 plus 0 plus 0, 0. Same way 0, same way 0. Now we are calculating Cj minus Jj. I will explain their interpretation in detail. Let me finish with it. I will take then 5 minutes break after finishing it and then explain you again. Now Cj minus Jj. Cj minus Jj means how much contribution minus the profit. My contribution over here is, we don't need it for it, 20 minus 0. It would be 20. Contribution is 30, 30 and Z is 0. 30 minus 0. 0 minus 0, 0 minus 0, 0 minus 0. What we check? We check in the last row. Last row is Cj minus Zj. Okay? Now, in the last row, Cj minus Zj, there is positive entry. So, current solution is not optimal. This is my response to that, right? हमें दिख रहा है they are positive. See, 20 and 30 is 0, 0, 0. Means still we have something 0 and then we have the positive also. If some entry is there, a positive entry is there in the last row of Cj minus Zj, means the current solution. Our current solution was this. Or the basic, this was the current solution. So this current solution they are saying is not an optimal. Yes, it's a basic feasible solution, but not the optimal solution. Why? Because still positive. If we enter y in place of any of them, then or we place x in place of any of them, they will be contributing 30 and 20 respectively. And we know if we replace it by x, it would be 20 contribution. If we replace it by y, it would be 30. So what we will do is, we will say which is the highest, this one. We want to replace it with it. Or I can say, this is my key column. This is my key column. And or we can say this is my entry variable. This is my key column. And this is my entering variable also y. Now, let me explain you one more concept. One more column which we need to add, that is of ratio. Ratio column, what we say? 36 divided by 3. My key column, the value of the key column, 36 divided by 3 comes out to be 12. Here 50 divided by 2, 25. Here 60 divided by 6 comes out to be 10. What I have done? 36 divided by 3 comes out to be 12. 50 divided by 5 comes out to be 25. 60 divided by 6 comes out to be 10. 50 divided by 2, 25, because we have to consider the key column. Clear? Now, we have to see now which one is a minimum, which is contributing minimum, this one, S3, 10. Then this 10 would be my departing variable. Or I will consider this as my key row. Is it clear? Now, this is the key row. And the number which is on the intersection of both, that is 6. This would be my key number. This is a key number. I think as of now, understand these three parts. How we have calculated the key column, how we calculated the key row, and how we calculated the key number. Right? So now, and we know this is not my optimal solution. So I have to prepare the next table. And how to prepare the next table, I will explain you. Prior to that, I will try to explain you each part, how to interpret this. How do we interpret it? 3. How we interpret, what does it 3 means over here? What does these rows means? What does this means? But after the break of 5 minutes. First of all, I will sit, revise it. Just understand the concepts, how we have come up for this simple lex table, tableau 1. Right? And after that, I will explain you other different parts and how to go ahead. Okay, thank you. Take the break for 5 minutes.